Alright, hello. So tonight we're gonna finish up this music visualizer. We are going to probably also make a little video showing how to use it, as well as I think we might make a little video on how to use Strand Engine as well, or how to compile those examples, since that'll be needed for this. Anyways, I actually made an audio visualizer off stream just in like 10 minutes because I got an idea for it. I called it Bouquet. I'll show it right here. So this almost has similar idea to the waves, the wave interference. The bigger spheres are lower frequencies, and the smaller, bigger repeat, or the smaller, more frequently repeating spheres are the higher frequency. So like the big spheres show the lower frequencies and in the audio. So these are just some default. The core part of this program is supposed to be, though, that people can code their own music visualizers with GLSL and shaders. Hey, Scallywag. So the next visualizer I'm going to make, though, is going to be a 3D sort of waves. I don't know how to describe it. It's going to be like a feedback effect. I guess I'll just call it graph. Okay, so for this one we're going to have no geometry, it's just going to be a simple volume. We are going to sample the buffer because it's going to be a feedback effect. And it's going to be 3D, so we're going to have the ray position or ray direction. We're going to keep it like this. Not sure if I want the ray position to actually, I think I might try starting it out at 0. And then we're going to create this for loop looping through T. This is going to be the ray marking through the volume. So then our position is ray position plus ray direction times T. And I just realized because ray position 0, we actually don't create ray position yet. And now in this we're gonna sample the audio as a graph. I don't know. You know what, I should actually do this without a for loop to begin. And we actually want to make a function for this. I'm gonna call it, I say, for sample audio. So what this is going to do is it's going to interpolate between these audio samples manually. So first of all, we're going to multiply it by this and floor it. Just like that. Well, that's playing all the frequencies. Alright, so we need to interpolate between F and F1, or do T for target. Hold on, wait. I can just write this as a mix instruction. So we just gotta clamp this to minimum 63. And mix audio F with audio T. And then we mix it by x minus f, which is basically like fract x. Oh wait, and then we gotta load the shader. And it's not outputting anything right now, so wait, let's do frag color equals vector. uv.y minus sa uv.x. So I need to clamp this. This actually doesn't need aspect correct. Oh yeah, and audio needs to be audio.y, or actually audio.x. I'm not sure if I want to use y or x. Y is more convoluted, I might use y. It's a smoother result. Alright, so then we're gonna get the difference between the Y and the audio value, so this will make a graph-like effect. Yep, there we go. So that is the effect I was looking for. So now we're gonna create like a feedback effect of this, where it like fades out over time. I don't know. You'll see. Mix. Texel fetch. We're going to pack this actual string position here to the vec4 component. Alright, so maybe.zw, or actually this needs to be ivec2, and then however much we want to blur it, I'll just do 0.5 to begin. Oh yeah, I'll remove the level of detail. Oh wait, error. Oh, I forgot. Parentheses there. Too much data in type constructor. Fragment shader 34. My cat is messing around behind my computer. I swear to God, if it unplugs the internet cable, it is literally rubbing its head against the internet cable. Can you feel the internet? I think it knows it gets my attention. Too much data. Oh, it's right here. Oh yeah, should clamp this. So I think this is what I'm going to do for the graph actually, just a super simple feedback effect. I don't actually think you need 3D for this. Yeah, I think that's good. Let's try some different music. Oh, so it's actually offset incorrectly. uv.y. This should be times 2 minus 1 or plus 1. Here we go. Now it's an actual proper graph. Yeah, I think that's a pretty good audio visualizer. feel like it almost needs to be more, yeah, darker. See if we can do that. Maybe make it fade out. Oh god, no. Let's try even more convolution. Try less. I still think the Y is perfect. There's a better way to add a feedback effect. Oh wait, what if we did negatives? Wait, we could actually do negatives here. Hold on. Oh yeah, here we go. Oh yeah, and then if we limit, it's not being limited to 1 anymore, is it? No, so if we limit it to 1, get these like ghostly spikes where it moves. And that's cool. Well, you'll be able to use this music visualizer soon. Yeah, like that. So it like blurs where it's moving. Like a graph with motion blur. Yeah, let's try some different music. Oh man, look at it. Oh, this is good. You know, it almost looks like it's not showing higher frequencies there. Or maybe they're just so quiet they weren't really showing. Oh, here we go. Hold on, I will be right back. Alright. I think we're going to make the video on how to use shader view now. So we're going to turn off the music and we're going to film a video. So to turn off video capture here. So I'm just thinking, on Linux, also there's a few more things I gotta add to the README. Audio data is a fours audio.x audio data is 0.05 seconds. Data run through size 64 cosine transform. For x is raw, scaled / normalized. Y is times convolution. Z is 2 times convolution. Z is 3 times. Okay. So one of the things is that I need to actually look up is, does Linux SDL require user install SDL lib? I think it does. SDL distribute Linux game install libs. All right. If program does not run on Linux, try installing libsdl2 and libpng packages. Okay. Now let's make a. Oh man. So this is gonna be probably gonna want to move this to a different folder. Also, let's build the 32-bit. Oh yeah, we're also gonna push this to Bitbucket. Yeah, so you know what? We might actually push this to Bitbucket before doing the video. I'm just going to create one zip file that has all Linux and Windows binaries. Actually, never mind. I'm going to create a new folder for this. This actually might be something I do off stream, uploading this. Yeah, I think that actually is going to be something I do off stream. Okay, let's just package this zip file. Win32. Alright, there we go. That's the 32-bit version. And I think I might include the source with that as well. I think, no, I'll do that differently. As a separate file. And the 64-bit libs. There we go. Now build the source. So we're gonna do a README for the source. Pile on Windows, open shader view, VX project in Visual Studio 2013 or higher. Ensure project is located 2 directories down from Strand Engine directories inside engine folder of Strand Engine. Or the library paths are set up correctly. Build solution to compile on Linux. Run build full.sh. There we go. Oh wait, I'm actually gonna need to link the Strand Engine on here. So this is actually gonna get changed to the actual link of Strand Engine, I believe. Or that's what I'll do once I actually have a link for it. Alright, awesome. So now we can actually make this, we can actually do this video. I'm just gonna start recording. I'm just gonna go. This folder. Alright, hello there. Today in this video I'm going to show you a little app that I made a while ago that I'm finally releasing called Shader View. This is a little shader viewer that has... Oh god, I just forgot. Oh my god, wait. Stop recording. We gotta add something. To the README. I almost forgot. Capturing video requires FFmpeg. Ensure ffmpeg.exe is accessible via path. Look at, I almost forgot that. Okay, let's try this again. Alright, hello there. Today I have a new app to show you. I've been working on this on and off. Hello, today in this video I'm going to show you Shader View, a little app I made. You can download this off my website for free. It's also open source. The full source is available. Here I've downloaded the 64-bit version. I'm just going to show you how to use it. I've extracted it here. It's a console-based program, so when you open it here, you'll get a console. You can type in help to get all the list of commands, simple application to quickly help you view and develop shaders. Today I'm going to show you some of the key parts of this that I think make it a special shader viewer. So first of all, along with it, you can see in the folders here, we've got some effects and examples. So the first one I'm just going to show you is just a blank so we need to add the path as well. So this is just our plain UV shader. Then we also have a buffer example. So here it's doing motion blur by reading back to the buffer. So you can see here, the shader viewer has a bit of a custom shader syntax. You have vertex and fragment shaders in the same program. This makes it a lot easier to write, I think. You can just access the current buffer by doing buffer 0 or whatever buffer number you want to access. It supports any number of buffers. One of the amazing things about this, if you look at the list of commands here, I know it is hard to read through all of them, but there is a capture command, captures images and videos. So you can actually capture, so we're going to set it to 60 FPS. And so if we wanted to capture 2 seconds of video, we would do capture 120, 60 times 2 frames. And so this is one of the key features of this program, is the ability to render out videos using FFmpeg. So this is really nice for slow shaders that you can't actually render at full 60 frames per second. So in this video, I'm only going to show you a fraction of what this program can do. If you want full information, go to the README. Like I said, the source is also available. So now I'm going to show you one of the key parts that I use this program for, that I love it for, audio visualization. So if we go shader 0, examples / audio.glsl, you'll see here it initializes audio. One of the things I just want to say is this audio visualization and feedback only works on Windows. Now let's put on some music. So you can see this simple audio example just displays the audio frequencies as a sort of colored bar graph. To read more about what the X and Y, what the red, green, and blue colors are there, it explains in the README what data is in the audio buffer. So there are also 5 different audio visualizers included with this. And so one of the key parts of this program, you can program your own audio visualizers with shaders. So I'm going to show you some of these. So this first one is called bars. And it's not this. This is a 3D gray marked bar graph where each of the bars is actually a light. So let me show you this. So then another one that we have is Disco, another similar ray trace one. So this one is actually colorful. It has a similar idea of ray traced boxes that also light up our lights. So one of the most awesome parts of this, though, is the ability to just modify your own audio visualizer. So for example, if we take this bars shader, I was thinking about showing how to customize this in the video. I don't think I'm going to do that. Is there anything I want to close with? Nope. Okay, so yeah, actually there is. So yeah, if you want to download this site, there is Windows 32-bit, 64-bit binaries on the website, Linux 32-bit and 64-bit binaries that are compatible with at least Ubuntu. The source is available, so if you have another distro, you should be able to compile it. It just uses SDL and OpenGL. Anyways, thank you for watching. I hope this program is useful to you. Alright, there we go. It would be funny if I forgot to record there. Okay. Now we're going to do shader view. Or sorry, we're going to do strand engine. So yeah, I'm just gonna straight up show it off. Okay. Let's get started. Hello, today I'm going to show you Strand Engine. This is a giant collection of C code that I've been programming for years now. I was trying to make a game engine in C and I ended up just not finishing it. So I figured why not release all of this code to everybody. So today I'm going to just show you some of the examples I have, or one of the examples I have. So this should give you a basic idea of how to get started. So once you've downloaded this, I first of all just want to say you should go ahead and read the README. It's 10 kilobytes. That is basically a lot of the notes on this engine, how to get started. If you're on Linux, there is a .sh script for installing all the required libraries, and on Windows, the zip file comes with all the libraries you need for this. You should just be able to unpack this, open up the Visual Studio project, and compile it. So you can go up here and open the engine GUI example project and main.c. So I'm just going to first of all go ahead and compile it and show you what this does. So as you can see, the engine's actually fairly minimal, 83 kilobytes. It does rely on the SDL library as well. So here you can see it's just a very simple GUI, quick background to scroll. Got a text editor. It shows off. So all of this text editor and everything is actually coded in the engine. It does glyph and font rendering, the OpenGL. All that source is now available if you're interested in it. And to just show you a bit of what the code looks like, the engine is designed after a C header-only library, so you can see it's basically all headers. You must include these in a specific order. It's not particularly well organized, but you can see some of the general syntax here. load asset, set frame rate slash tick rate, create object, create GUI component, and add that to an object. It follows generally the same structure as a lot of engines these days. So I think if people can't even use this, there's a lot to learn off of it. I have the source link to this in the description as well as the full zip download. So I hope this is useful to someone. Thank you for watching. Okay, there we go. So that is our video on Strand Engine. Now that's basically it, I think. All right. I wanted to get this done tonight so I can push it out to my website and also push ShaderView to Bitbucket. Yeah, I hope you enjoyed this short stream. We just made an audio visualizer. I think we're actually going to make an audio visualizer every once in a while as well, because it's just a lot of fun to make these, and I really like having them. I mean, we make a shader every day, so we can just make an audio visualizer like each week as well, right? It's easy to turn these shaders into audio visualizers. Anyways, I will see you guys around. I hope you have a good day. If you're in the Discord, I'll be posting the link to Strand Engine source and shader view once that download link is up. Bye-bye. Have a good day. Thank you for watching.